In this video, I'm going to talk about the product rule for derivatives. So let's say I have two functions, f of x and g of x. I would like to know what is the derivative of product of these functions. That is to say, I want to find out d over dx f times g of x. I would like to know what the derivative of product of these two functions. Now let me go ahead and define a new function, uppercase f of x, which is, by the way, f times g of x. And as you know, the definition of product for functions is f of x times g of x. Now I'm going to apply the derivatives definition. F prime of x is going to be limit h approaches 0 f of x plus h minus uppercase f of x, all of it divided by h. Now that is going to give me limit h approaches 0. Now what is f of x plus h, by the way? Here we need to find it. So f of x plus h, which is literally going to be replace x by x plus h here for f, replace x by x plus h. So that's going to give me f of x plus h times g of x plus h, and then minus f of x, uppercase f of x, which is lowercase f of x times g of x, and all of it divided by h. At this point, what I'm going to do, I'm going to apply a sort of simple trick. So what I'm going to do to kind of make things more reasonable, I'm going to subtract f of x plus h times g of x and add f of x plus h times g of x to the numerator. And why am I doing it? So that I can separate things out. Now from the first two terms, which is this one and this one, I can factor out f of x plus h. If I do so, I will be left with g of x plus h minus g of x. G of x plus h minus g of x. Now from the second two terms, this one and this one, I could factor out g of x, since both of them have g of x. If I do so, I get f of x plus h minus f of x, and all of it divided by h. Now I'm going to apply the rules for limits. So I could break this limit down into two limits as sum, okay? Then apply the product rule for limits to simplify this to this. So think of it. So this is the sum, okay? So this is where it is. So I break it into two pieces. This is going to be one limit and this is another limit. On the left hand side, I have limit f of x plus h times g of x plus h minus g of x. I could write it as product of limits. That gives me limit h approaches 0 f of x plus h times limit h approaches 0 g of x plus h minus g of x divided by h plus g of x, this g of x, this doesn't have h in it, so I can just move it outside the limit, times limit h approaches 0 f of x plus h minus f of x divided by h. Now I can evaluate the limits. By the way, it's very easy to evaluate them. Look, limit h approaches 0, f of x plus h is going to be just f of x, right? That's what the definition of limit. Now, then this limit is nothing but g prime of x. Then this plus sign, plus, this is g of x, so I'm going to write g of x. And this is nothing but f prime of x. So we just found out that derivative of uppercase f of x, which is the product of these two functions, is nothing but f times the derivative of g of x plus g times the derivative of f of x. So we can write it all together here. So this is going to be equal to f times the derivative of g with respect to x plus g times the derivative of f with respect to x. We also sometimes write it as f times g prime plus g times f prime. So the derivative of product of two functions, which is this, is the derivative of one function multiplied by the other function and then switch the functions. Or derivative of f and g is going to be f times the derivative of g plus g times the derivative of f. So this is how you find the derivative for the product of two functions. I hope that this discussion was helpful. Thank you very much.